in this first section of this new unit, we're going to be talking about the Pythagorean Theorem. And maybe I've talked about this in the past in other math classes, but we're going to kind of look at it again. And if you remember, the Pythagorean Theorem is just this little formula. It is a squared plus b squared equals c squared. And we can only use the Pythagorean Theorem on right triangles. And we use it to find the missing side of a right triangle. And where the a and the b and the c come from, if you look at this diagram in the box, if you start at the big A and go directly across from it, that side is technically called little a. Same thing if you go to the big B and go across from it, that side is the little b. And if you start at the big C and go across, the side across from that is a little c. So that's where the A, the B, and the C come from. The A and the B are the legs of your right triangle, and the C is always going to be the hypotenuse. And remember, the hypotenuse is always this kind of more slanted side, and it's across from your 90-degree angle. So what I like to do when I label my sides, I always start at my 90-degree angle, go across, label that as my C. It's really nice because it doesn't matter which leg you make your A and which leg you make your B. It just doesn't matter. The one that does is the C, and that always has to be your hypotenuse. I like to think that it's always the slanted side. And my legs are always my straight sides. Straight up and down sides. Okay? So if we apply this in an example, take a look at number 1, okay? We want to find the side of the missing right triangle. Well, here's our question mark. I'm going to label that with our X. That's our missing side. And then label your A, your B, and your C. So again, when you label your A, your B, and your C, you always start at the 90 and go directly across from it. That's always, always, always your C. The other two do not matter. I'm just going to make 6 my A, and I'm going to make 8 my B. You could have flip-flopped them. You could have made 6 your B and 8 your A. That does not matter. The hypotenuse always has to be the C. So we just take those values and plug them into that formula. So A squared, which is 6. So we have 6 squared plus B squared equals our C squared. Take those values and plug them in the right spot in the word formula. And then you just simplify it down. Solve for that missing variable. So when we solve, 6 squared is 36. 8 squared is 64. And we don't know what x squared is. That's what we're trying to find. And then clean it up even more. 36 plus 64 is 100. We're still solving for x. X is not completely by itself because it has that exponent. So we need to get rid of it. And to get rid of it, think the opposite. So the opposite of squaring is square rooting. So once you get down to that variable squared, you just square root both sides. That gets rid of the exponent, so we're just left with x. And the square root of 100 is 10. And then it'd be 10, 8. Because it did have a unit of measure. So whenever you have units of measure, you have to label your answer. If it didn't have units of measure, if it just had 6 and 8, you wouldn't really need to worry about it. But because it gave us feet, we have to label our answer in feet. So there you go. That is how you use the Pythagorean Theorem. And we're going to take a look at a few more examples just so we can get more practice and a better look. Okay. So with number 2, label your A, your B, and your C. And always start at your 90 and go directly across. Again, it does not matter which one's your A and which one's your B. You just always have to make sure your hypotenuse is the C. I'm going to put an X over that question mark because that's the side we're trying to find. And then plug those values into the correct spot into the formula, which is written right above here. Okay. Again, A squared is 12 squared plus B squared is equal to C squared. Plug those values in. And then solve. Well, before we solve, let's just clean everything up and simplify everything down. 12 squared is 144. And then 15 squared is 225. This is a little different from number 1 because our X, our missing side, was our C. So we just kind of combined like terms and simplified it down this way, that way. And 2, one of our legs was missing. So our variable isn't necessarily by itself right away. When this happens, what you need to do is just solve for that variable. So move that other leg over. So to move it over, we just do the opposite. So we're going to subtract. Now we have that variable by itself. 225 minus 144 is 81. And again, once you get down to this point, you just have to square root both sides to get rid of the square. And the square root of 81 is 9. And if you need help with doing that, just plug it in your calculator. You need to pause because I'm going to go ahead and move on to the next example. Or feel free to rewatch this section again. I'm going to go ahead and move on. Pause if you need to finish writing anything down. 3. Again, label your A, your B, and your C first. That's your first step every time. Start at your 90, go across. That's your C. And it doesn't matter which one you make your A and which one you make your B. The only one that matters is C. And again, this is written at the top of your paper, but I'm going to rewrite it. Well, that was weird. That's not working. So I'm going to rewrite it A squared plus B squared equals C squared. Plug those values in that you labeled into the right spot. So it will look like this. And again, I'm going to mark my question mark with X. So X squared plus 2 squared equals 6 squared. Clean everything up, so go ahead and square everything you can. Can't really square X, so we just leave it as X squared. 2 squared is 4, 6 squared is 36. We are solving for X, so we need to move that 4 over. Do the opposite, so go ahead and subtract. So we get X squared is equal to 32. You still need to get X by itself, but once you get down to this point, all you have to do is just square root both sides. Get rid of the square. And 32 is not a perfect square. But if you read back into the at the top of the directions, right here, it says round your answer to the nearest tenth. Well, the first two we didn't have to because they were perfect squares. Okay? And while we're here, don't do what I just did. Make sure if they gave us a unit of measurement, make sure you label. Make sure you label. They were given centimeters. Make sure right now you put centimeters there. But for these first two, we didn't have to round because they were perfect squares. This third one, we do have to round because if you notice 32 is not a perfect square. It says round to the nearest tenth. So when you plug in your calculator, you should get about 5.7 when you round. Remember that little squiggly equal sign? That just means approximately. 5.7 millimeters. And make sure you label. Again, pause if you need to. If you finish writing anything down, we're going to go ahead and move on to our last example, number 4. Then always start with your 90. Go across, that's your C. And then your A and your B, it doesn't matter. Those are just your legs. Plug those values in to the Pythagorean Theorem. And you don't have to memorize this either. You're going to have a formula sheet that has this theorem on there. So don't stress about having to necessarily memorize it. You just have to be able to recognize it. Because you'll have a formula sheet with this on here. So I'm going to put an X over that question mark. That's my missing sign. So we have 2 squared. That's 5 squared. That's X squared. Clean it up. 2 squared is 4. 5 squared is 25. And 4 plus 25 is 29. And our very, very, very last step, once you get down to this point, we just square root both sides to get rid of that square. And again, 29 is not a perfect square, so you're going to have to round. And when you plug it into your calculator, it should be about 5.4. Remember, when rounding, if the second number is bigger, 5 or above, you round up. If it's less than 5, then you round down. And there you go. If you need to, watch the video again. Go ahead.